first, let's dig into what confidential computing is in general. So tell us what a confidential computing platform is and how it works.
Absolutely. So the idea is that you can compute in the cloud. Let's say you can do analytics or machine learning, but while keeping your data encrypted. So there's a lot to unpack there. So the idea is that your data, confidential data, will be protected by encryption, but at the same time, you can still do machine learning and data analytics on it. The cloud can see your data, so you can move your sensitive workloads in the cloud. Cloud employees cannot see it. Hackers breaking into the cloud, even if they get root access on the machine, they can't see your data because it's in encrypted form at all times during processing.
That's really interesting. So, how is it that it's encrypted all of the time
Yeah.
in processing, but yet we could still do analytics on it or we could train a machine learning model on it?
Yeah, very good question. So I've done research in this space at UC Berkeley in my PhD at MIT, and now taking it to the company. And there's really two main approaches. One is using some advanced cryptographic mechanism that can actually compute on the data, and that one works in some settings, but it's still very slow for machine learning training and analytics. There's the other approach, the more recent one, confidential computing, which is based on hardware enclaves. So we're talking about specialized hardware that is now available in the cloud, which is awesome. And the idea is that this hardware enclave is in the processor, in the basically chip, creates like a hardware box. Now, in that box, the data actually gets decrypted, but only the metal can see the data. There's no human physically
Oh.
in that CPU box. Yeah. And as soon as it goes outside of the CPU box, basically outside of the die of the processor, there's an encryption key that's fused into the hardware that encrypts the data as soon as it comes, right before it comes out. So outside of this box and outside of the die, the data is encrypted on the bus in memory. So anywhere a human can access and look at it, it's in encrypted form.
This is a hardware solution, not a software solution.
Very good point. Yeah. So the security and the trust comes bootstrapped from the specialized hardware, but then you need the software stack on top of it, which is what Opaque provides to be able to work with this hardware. Because to work with this hardware requires a lot of expertise, like expertise on how do you manage the keys for this hardware. There's something called attestation where you can check that the hardware deployment was done correctly while being remote. There's things like ensuring end-to-end policies on who can see the result of, let's say, the model you trained or the prediction results. There's the scale out. How do you scale with this hardware enclave? So there's this big software stack that you need to run on top of this hardware in the cloud if you want it to be frictionless. So the whole idea of Opaque is to provide the software stack so that data scientists can use this without any friction. They don't have to think of confidential computing. They don't have to think of how hardware enclaves work. They can just use the software stack and run their usual pipelines unchanged. And then they don't have to think about all the complexity.
Very cool. I think I'm starting to understand it. So, the enclave part of it, is that like the hardware specifically, or it's kind of the whole system
Yes.
incorporating the software? Oh,
Yeah, very, very good question. So, yeah, the enclave is the hardware piece. It's the hardware enclave. It's specialized hardware provided by Intel, by AMD, ARM. So, most of the major hardware vendors right now have a hardware enclave technology, and it comes shipped with the modern server architectures. So, for example, Intel Skylake has it. Um, so if you look at AWS, if you look at GCP or at Azure, they have these hardware enclaves already available in the data centers, and you can just choose VMs that have that enabled. But then to handle all this complexity of how you deal, the expertise that you need, we have the software stack that Opaque provides, so that the user doesn't have to think, doesn't have to worry. Oh, am I using enclaves or not? How do I do with the keys? How do I push my data in that? How do I do scale out? They don't have to worry about any of this. They just run their usual system. So it is like a synergy of software and hardware, but the hardware enclaves itself just provides the hardware part.
I gotcha. And so I imagine something else that the software is critical for is ensuring that this encryption is very efficient. Like, I suspect
Yes.
that there's a risk here that if you have all of this encrypted data and you're training like a large language model, there's a huge amount of information in each round of training of stochastic gradient descent that is going to have to come out of encryption and then
Mhm.
have outputs be decrypted again very rapidly. So yeah, I'm guessing from your head nodding.
Absolutely. Yeah. Yeah, that's absolutely very good question. And it used to be normally that encryption would add a significant overhead in performance. But the nice thing is that right now this encryption is in hardware. It's called ASNI instruction, which encrypts extremely fast. So it's almost never a bottleneck. Um, depends on your workload. It can add a few percentages in performance overhead. In other, really the main actually performance overhead comes from going in and out of the enclave, so you have to have a well designed system, and that's another thing that our software stack helps with. But the other exciting thing, because you mentioned generative AI and you mentioned the large amount of data, we now have GPU enclaves thanks to NVIDIA. So these hardware enclaves used to be just on the CPU, and a lot of the solutions they are for the CPU. But fresh off the press, NVIDIA is providing hardware enclaves in their Hopper architecture. And this is, I'm not advertising NVIDIA, but I am genuinely super excited about this. It's like awesome. So now we can actually run Gen AI at performance that is similar to not encrypted and insecure computation.